All right, so they call this section 16.2 solving exponential equations, and I'm sort of bummed that they only solve exponentials and not logarithmic equations too. So I will add this into your review, but knowing how to solve an exponential equation will lead directly into solving a logarithmic equation. Okay. So I'm going to do it a little bit differently than the book does it. So I'm just going to kind of scroll down to the very bottom and just choose problems to do and go from there. Okay, so the first thing they do is show you how to do this graphically, or maybe I should say remind you how to solve graphically. Okay, we've done this already. So quick refresher on this, how do I solve an equation graphically? With my calculator. You type it in, okay, good. Where do you type it in? Good. Okay, so then I'm going to type 4e to the 0.1x into my y1. Good. Okay, and then you hope for the best if you hit graph. Okay. I'm gonna not hit graph. I'm actually gonna hit a zoom 0 and zoom into my stuff. Just because I know better. When you're working with a line at 60, it's probably not gonna take you there. Oh no. Alright, so nicely I can at least see both lines, but they are not intersecting in my window. So I have to hit window, and I'm going to have to, actually I guess I could just do a zoom out. Should we just do that instead? Let's do that. Let's just hit a zoom out, and number 3, and hit enter. Let's do that. Oh, that's nice. Perfect. All right, so then how do I find the intersection? What do I hit?
Second trace.
Second trace, number 5. Enter, enter, enter. And the x value is the answer that I'm looking for, and I see 27.08. Let's call that 1. Oh, that's a highlighter. 27.081. Anybody else get that number? Good? All right, ready for a blanket statement? Okay. So, when you're working with exponential equations and logarithmic equations, you pretty much get a lot of decimals. Okay, so this is the one kind of section where a decimal answer is going to be okay to give. Okay, so what I want you to do is, for a blanket statement, we're going to say we are going to round to 3 decimal places. Okay, so we'll get pretty exact, so we're going to round to the 1,000th. Everybody got it? What are we rounding to? 1,000th. Do I need to do another example of how to solve by graphing? That was old news. Alright, let's do a solve. This is going to be fun. Okay, here we go. Number 1. So now we're going to solve this algebraically, so if you want to title your notes, Solving Exponentials Equations Algebraically, you can, or just write an example. Okay, so the first step in solving any exponential equation, or any logarithmic equation for that matter, is to basically condense it into its most simple form. Okay, so this is a exponential equation. Can we make it into its most basic form?
Sure.
Okay, so how could we do that? Okay, so the most basic form would be like the base to the x is equal to the y. Okay, so in our case we have like a minus 10 out there. How do you get rid of that minus 10 piece? You add 10. Good. Okay, so we have 6 to the 3x minus 9 equals 7. Okay, so now this is in its most simplified exponential form. I have a base, I have an exponent, and it's equal to the other side. Okay, so what I'm going to do is I'm just going to simply convert to the other form. So if I'm an exponential form, I'm simply going to convert it to logarithmic form. Okay, pop quiz. What's the logarithmic form of this? Okay, remember that part in your notes that you highlighted and starred and made it in really pretty colors?
Is it log 6? Log base.
Yeah, it's the one that goes, it goes b to the x is equal to y. Remember this? I told you to circle it and star it and do cool stuff to it so you'd never forget it. Maybe tattoo it on your wrist. Whatever. Okay, so try again. What is the logarithmic form?
Log base 6 to 7, and I say to 7.
Yep, of 7.
3x minus 9.
Good. Okay, so now all I have to do is put the log base 6 to 7 into my calculator, and we all remember how to do that, right?
What's a calculator?
It's that pretty yellow thing on your desk.
Oh,
Okay.
That was a really old phone.
Okay, how do you do a log with a base? What do you type? Okay, so yeah, a quick way to do it is math, alpha math. 7, and so anybody else get 1.086? That was like almost the answer we got to the last question, wasn't it? That's kind of strange. 1.087. Okay, and now I just have this nice little linear equation to solve. So how would you go about solving this? What? Is it not 87? Oh, I don't know. Good question. So yeah, we add the 9. So, ooh, I can do that. That's 10.086. And then what? Then divide by 3. So I'll let you guys tell me what that is. What's that number divided by 3? 6 to infinity. Pretty easy? What else do we want to do? Gosh, these are just so easy. Alright, I like this problem up here. Let's do this one. Okay, so second example. 450 times e to the 0.4x equals 2,000. How would I go about solving this? First step.
Log 450.
Careful.
Oh, there's an e there, right?
There is, and there's the big fat 450 in front of it.
Divided by 450.
Divide by the 450. We got to get rid of the number that's being multiplied by that base number.
Base number is always going to have the exponent on it.
Right,
Okay,
right.
that makes sense.
4.44444444.
Okay. So now convert it to logarithmic form. Ooh, nice. Okay. See how it has a base of e? So you could do a log with a base of e, but it's simpler to just say a natural log of 4.444444. However many 4s you want to write. That's true, but it's funner to do more 4s. Okay, so we would just type that in the calculator. My last step is going to be to divide by 0.4, right?
Yes.
So go ahead and type the natural log of 4 with a lot of 4s after that, and then divide by 0.4.
I can figure out the natural log.
Yeah.
3.729.
3.729. Anybody concur?
It's not infinity, so
Okay.
I'm good.
I don't think you're going to get any infinity answers.
One day.
Maybe a no solution?
He has a determination.
I mean, it's possible to get infinite, like infinite solutions, but not infinity as a solution. Like that's not a number. I can't be like the answer is infinity. I can say
Don't
the answer
ruin
is
my dream.
infinite solutions.
I got 2.408.
Uh-oh. Let's double check this. So when you type this in, do you notice that a natural log pops out a parenthesis? Actually, the regular log does too.
Oh, no.
So you have to do 4.4444444. Oh, I typed 4 a lot. End the parenthesis and then divide by 0.4 to do that correctly. So I agree with 3.729. Pretty easy? Okay, let's do a hard one. This is probably like the hardest one you'll see. There's actually a couple of different ways to do it, but alright, let's see if we can figure this one out. You ready? Bless you. So this is kind of a strange one where we have two exponential pieces. Can we just knock? Oh, in the other room? Oh. Should we knock back?
Yeah.
Okay, so the way I'm gonna play this is that I'm gonna pick one of those sides to be my base. So I'm gonna use the left-hand side to be my base. So I'm gonna say I want this to be my base. Okay? And I'm gonna put it into its most simple exponential form. So the first thing I'm gonna do is get rid of that 10. So how do we get rid of the 10? Divide by 10. So, yeah, would you agree that that's e to the 6x is equal to 1? Nope. Let's use decimals since we're in the mood. I know, not really, let's be honest.
I can see her like wincing.
It did hurt a lot. Huh? I wrote a decimal. No, right now it's okay. It's probably a little purple, but it's fine.
Okay.
Okay, so exponential form, what do I do now? Log form, okay, so what's my logarithmic form? Ooh. Okay, fair enough, you can do a log of base e, or you can do an ln of 0.5 e to the negative 3x equals 6x. Are we alright here?
Yeah,
Throwing pencils and calculators today.
That's the wrong direction. It's all good now, we're good.
Oh, phew. Alright, so, do you guys notice that I have two x's involved right now? I have an x on the left and an x on the right. So, anybody know what I should do? Huh? Could have been right. I didn't hear you. Negate it. Nobody's got an idea? A thought process? An educated guess?
Finding 6 versus 5.
But we gotta get both the x's on the same side. So we somehow have to get up into that exponent of the e. Alright, so this is what we're gonna do. We're gonna use those fancy properties we just talked about. Okay, and what I'm going to do is I'm going to expand. Okay, so right now this is in a condensed form and I'm going to expand. So do you see how I have a 0.5 that is being multiplied by an e that has an exponent? So when I expand this, I'm going to expand it into two separate logs. So it's going to be a natural log of 0.5 and then I have my natural log of e. What's going to happen with that exponential piece? Goes in the front. Okay, so would you agree that this is going to be the natural log of 0.5 plus negative 3x times the natural log of e. Everybody follow that? Absolutely. Okay, so I could have just said minus instead of plus a negative. I just wanted to show my work to make sure that everybody was on the same page, though. Everybody follow that? Okay, so now what can I do? Does anybody see what I can do? Not yet. I want to get my x's on the same side. Ooh, see this right here? The natural log of e. What's the base of a natural log? E. So that first property that you wrote down, if you have a log that has the same base as what it's of, then it just becomes 1. So the natural log of e is 1. So really, this now says 1 times negative 3x, which I'm going to say is just minus 3x. Now what would you do to get the x's on the same side? I would add 3x's. So you would probably agree that that would be 9x's?
Yes.
Okay, now what's my last step? Yeah. Divide by, whoops, I wrote a point.
One more step. One more step.
One more. Okay, so type that in the calculator, tell me what you get. Negative 0.0. Is there one more decimal? 7. 7 7?
Yeah.
Oh, so 7 7. I got you. What'd you think about that one? That's a good problem. I like that one. Makes you think a little bit. So you feel good about this? That's all I have to show you.